Okay. So 1 upon 9x square plus 6x plus 5. Question number 11.
Okay. Okay.
So 9x square. So here you have to change your coefficient of x square as 1. That is the first step.
Okay.
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 So for changing the coefficient of x square into 1, you have to divide the entire equation by 9. Okay.
Okay.
Or else take the 9 as common. Anything. So when you take 9 as common, it will become x square plus 6x upon 9 plus 5 by 9.
Okay.
Now they are simplifying this 6 by 9 into 2 by 3. 2 by 3
Okay.
into x.
Okay, ma'am.
So now let's take the first two term and we can express this using the completion of the square method. So x square plus 2 into x into 1 by 3 can be written as a square plus 2ab.
Okay.
So a square is x square, which means x is a. 2ab is 2 into x into 1 by 3 means 2 and 2 will cancel out each other. A and x will cancel out each other. And b is nothing but 1 by 3. Right?
Okay.
So a square plus 2ab is equivalent to a plus b the whole square minus b square, isn't it? So the value of a is x and the value of b is 1 by 3. So it's x plus 1 by 3 the whole square minus 1 by 3 the whole square. So let's rewrite this x square plus 2x into 1 by 3 as x plus 1 by 3 the whole square minus 1 by 3 the whole square. 1 by 3 the whole square is nothing but 1 by 9.
Okay.
So they just rewrote that into x plus 1 by 3 the whole square minus 1 by 9 plus 5 by 9. And you can subtract this and you can write this into 4 by 9. And 4 by 9 can be written as 2 by 3 the whole square. So now this is in the form of x square plus a square. So x is x square, x is x plus 1 by 3 in this and a is 2 by 3. So again you have to use this 1 by a, tan inverse of x by a plus c form. So in this a is 2 by 3 and x is x plus 3. Just replace it. That's it. Can you follow?
Yes, ma'am. Yes.
Same, this question is also in the same form, but over here you do have a square minus x square. So we have to express this in the form of sine inverse of x by a. Okay?
Yes, sir. Yes.
So 1 upon x minus 1 into x minus 2. So here they gave the factors. So now we have to multiply the factors and frame it in the form of a quadratic equation and then you do it. Okay. So assume x square minus 3x as a square minus 2ab. So now you can write this as a minus b the whole square minus b square. So a is x in this and minus 2ab is minus 3x. So b minus 2b equal to minus 3 because a is x, isn't it? Minus and minus will cancel out each other. 2b can be written as 3 and b is equal to 3 by 2. So the value of a is x and b is 3 by 2 in this. So x minus 3 by 2 the whole square minus 3 by 2 the whole square. Understood? Yes. So that is how we will rewrite this. Okay?
Okay. Yes.
Yes. And you have plus 2 here. 9 by 4 plus 2 can be.
Okay.
You can take LCM for this. It will turn into 1 by 4. And 1 by 4 can be written in the 1 by 2 the whole square form. So now if you check, it is of dx by square root of x square minus a square form, which can be written as log of x plus square root of x square minus a square.
Okay.
The value of a is 1 by 2 here. The value of x is x minus 3 by 2. So this expression needs to be assigned to this variable.
Okay.
Just replace x's x minus 3 by 2. Here you have x minus 3 by 2. Here also x minus 3 by 2 the whole square. This a will turn into 1 by 2. Got it?
Okay, ma'am. Done.
So here, so this question also we are just rewrite this 8 plus 3x minus x square, and from the last two term you just take the minus outside. It will become minus 3x and plus x square. So now you rearrange. It will become square root of 8 minus x square minus 3x. So now it looks like a square minus 2ab. Again, you can use the completion of the square method. You can write it as a minus b the whole square minus b square method. Can you follow?
Yes, ma'am. Yes.
So again, you have x minus a and x minus b. You have two factors, multiply them and frame into an equation. And again, you have to do the same completion of the square method. And then you'll be using this formula.
Okay.
2x square plus x minus 3. So 4x plus 1 upon square root of 2x square plus x minus 3. You can take this quadratic equation as t. We can solve this using the substitution method. Differentiate both the side with respect to x. Let's change the question in terms of t. This 4x plus 1, 4x plus 1 will cancel out each other. 1 upon root t can be written as t power minus 1 by 2. You integrate using the power rule formula. And again substitute the value of t, which is 2x square plus x minus 3.
Okay. Done.
Okay. So over here, they just multiplied this x by 2 and divided by 2.
Oh, okay, ma'am.
Okay. And then they are splitting this denominator for these two terms. Okay.
Okay, ma'am.
So after splitting them, you just take the 1 by 2 constant outside. It will turn into 2x upon square root of x square minus 1. And this will be 2 divided by square root of x square minus 1. So solve it separately. Again, we can solve this part using the substitution method. Take the x square minus 1 as t, differentiate it, it will turn into 2x equal to dt by dx, and dx is equal to dt by 2x.
Okay.
So just substitute the question. 1 by 2, write the 2x as 2x itself, it will become square root of t. This dx will become dt by 2x. This 2x and 2x will cancel out each other, it will become 1 by root t. Again, you integrate them using the power rule, that's it.
Okay, ma'am.
The first part can be integrated. The second part can be integrated by using this form, which is log of x plus square root of x square minus a square. So in this, the value of a is 1 and x is x. That's it. At last, you have to club x, the result of I1 and I2, and you will get the final result.
Okay.
This is also same kind of question. They're just taking the 5 as common. So 5x minus 2 changed into x minus 2 by 5.
Okay.
They're multiplying this and dividing it by 6. So 6 times of 2 changed into 12, x into 6 changed into 6. Multiply and divide it by 6.
Okay.
Because when you integrate, when you differentiate this 3x square, you will be getting the result as 6x. For that purpose, we are just multiplying and dividing it by 6.
Okay, ma'am. Okay, yes, I get it.
And they're adding and subtracting it by 2 in the numerator again.
Okay.
Because when you differentiate 2x, you'll be getting the result as 2 for that purpose.
Okay.
So now they are simplifying this negative 12 upon 5 and negative 2, which turned into negative 22 upon 5.
Okay.
So they are taking this as one fraction.
Okay, okay.
And this is another fraction. Okay.
Okay, okay.
So this fraction can be solved using the substitution method. You take this expression as t, and you'll be getting the result as the numerator. Okay. And for
Okay,
this,
okay.
for this 1 plus 2x plus 3x square, you take the 3 outside. We'll be having x square plus 2x upon 3 plus 1 by 3. Again, you can solve this using the completion of the square method.
Square method, okay. Adding plus and minus. Okay.
Yeah. Adding b square and subtracting b square.
Okay, okay.
This is also same kind of question.
Okay.
The rest of the problems also same. Like you will be using the completion of the square only.
Okay, okay. Just a second, ma'am. Ma'am, mute-ல இருக்குன்னு நினைக்கிறேன் ma'am.
Hello.
Yes, ma'am. Yes, ma'am. Yes.
Okay. So let's solve this integrand
Okay.
using a partial fraction. Okay. So x upon x plus 1 into x plus 2 can be written as a upon x plus 1 plus b upon x plus 2. So you can split the two factors for a and b. Okay. So that is the first step.
Okay.
And the next step is taking LCM.
LCM, yes.
Okay. So multiply both the denominator and do the cross multiplication between the numerator.
Okay.
So the next thing is you have to equate the question to this result of LCM. You will be cancelling the denominators now. So we will be left with the numerators alone, which is x equal to a into x plus 2 plus b into x plus 1. So now we are going to find the values of a and b. So how can you find the value of a and b? By substituting the value of x as minus 1 in this.
Minus.
Because you do have x plus 1 as the factor. So when you substitute minus 1, this minus 1 and plus 1 will cancel out each other and b will turn into 0. So that you will be left with only one variable, which is a, and you'll be able to find the value of a. Okay. So when you substitute x as negative 1 in this, b turned into 0 and a became a into minus 1 plus 2, which is plus 1. So a into 1 is a equal to minus 1. So we found the value of a. And again, you do have x plus 2 here. So now we have to substitute minus 2 in order to make the a as 0. So let's substitute x as negative 2 in this. A will turn into 0 and b will become minus 2 plus 1, which is minus 1. So b will become negative b. Negative b is equal to negative 2. So from that we can say the value of b is 2. So we found the value of a and b. So let's substitute in this. So let's substitute in this equation. Okay.
Okay.
A and b.
Okay.
So a is minus 1 and b is 2 here. So now we can perform the integration. And we already know this. Integration of 1 by x is nothing but log x.
Yes, ma'am. Yes.
So integration of 1 by x plus 1 will give you log of x plus 1. Similarly, integration of 1 upon x plus 2 will give you log of x plus 2. Yeah. So now you can rewrite this. And here you do have 2 times of log of x plus 2. A log x can be written as log x the whole power a. Okay. So 2 times of log of x plus 2 can be written as log of x plus 2 the whole square. Can you follow?
Yes, ma'am. Yes, absolutely.
And log a minus log b can be written as log a by b. That's what they're doing here.
Okay.
That's it.
Okay.
So
Done.
1.5 question number 2. So in the question number 2, you do have x square minus 9 in the denominator, which can be expressed as x minus 3 and x plus 3. So here we do
Yes.
have two factors which can be splitted as a upon x minus 3 and b upon x plus 3. We have to use the same method. So after splitting them, you will be going for LCM and you will be cancelling the denominator and you will substitute x as plus 3 and minus 3 for finding the value of a and b. And then when you substitute the value of a and b, you can go for integration. Okay.
Okay,
And
ma'am.
then you will
Yes.
use the basic logarithmic formula, same method. So look at this question. This question contains three factors, a, b, and c. So you can write this as a upon x minus 1 plus b upon x minus 2 plus c upon x minus 3. Just take the denominators alone and split it. So now whenever we do have two different denominators, we'll go for LCM, isn't it? So you can take LCM now.
Yes.
After taking the LCM, just equate this part to your question. So if you equate your denominator to the question and the denominator to the LCM result will cancel out each other. So we'll be having the numerator part alone. So now you can substitute the value of x by putting various values in x. You can find the value of a, b, and c. So here you do have x minus 1, x minus 3, and x minus 2. So you can substitute the value of x as 1, plus 1, plus 2, and plus 3 for getting the value of a, b, and 3. So when you substitute plus 1 in this, you have to deduce this. You are getting the value as 1 for a. And when you substitute x as 2, you got the value of b as negative 5. And when you substitute 3, you got the value of c as 4. Substitute back and integrate it separately. 1 upon x minus 1 integration is log of x minus 1 and minus 5 upon x minus 2. Minus 5 is in multiplication. Just keep the minus 5 as it is. 1 upon x minus 2 will give you log of x minus 2. And 1 upon x minus 3 will give you log of x minus 3.
Okay.
Clear?
Yes, ma'am. Yes.
Again, you have three different factors. Use the same method.
Okay.
So you have x and 1 minus 2x here.
Okay.
So x into 1 minus 2x, you just change this into a quadratic equation by multiplying it. X into 1 is x and x into 2x will become 2x square. So we will be using the remainder theorem now.
Okay.
So you have 1 minus x square in the numerator and in the denominator you do have x minus 2x square. Okay. So let's divide this.
Okay.
You write the numerator inside as the dividend and take the denominator as the divisor. Okay.
Okay. Okay, ma'am.
So 1 minus x square can be written as minus x square plus 1. They're just writing in the degree wise. Okay. So minus x square plus 1. And they are similarly, they are rewriting this x minus 2x square as minus 2x square plus x.
Okay.
So now let's do the division. So you can take the first part of this and this. How do you do division?
Oh, yeah.
You will write the dividend and then divisor as the denominator. X square and x square cancel, minus and minus cancel. Will be having 1 by 2 as the quotient. Okay.
Okay.
So now 1 by 2 can be multiplied with your divisor and write it over here. So 1 by 2 into minus 2x square will become minus x square and 1 by 2 into x is x by 2. So now let's change the sign. Minus will become plus, plus will become minus, and this plus x square and minus x square will cancel out each other. This x by 2 will become minus x by 2 and just write the plus 1 as plus 1 itself. Okay. And what is remainder theorem? How will you write?
Quotient plus remainder by divisor.
Quotient plus remainder upon divisor. Isn't it? So here you have a quotient 1 by 2 and remainder is here and divisor is I mean, that is divided. Divisor is here. Okay.
Okay. Yes, sir.
So they're just taking minus 2x square plus x as x into 1 minus 2x again.
Okay, ma'am. Okay.
So 1 by 2 integral 1. When you integrate 1 with respect to x, the answer would be x only.
Yes.
So it's 1 by
Yes, ma'am.
2x.
Yes.
And for
Okay.
these, x minus 2 upon x into 2x minus 1. You can reuse partial fraction. It will become a by x plus b by 2x minus 1. Okay. So now take LCM. It will be x into 2x minus 1. You do the cross multiplication. Okay.
Okay. Okay.
So now this denominator and this denominator will cancel out each other. Equate the numerator alone. By putting the value of x, you'll be able to find the value of a and b. You know how to do it,
Okay.
right?
Yes.
And then you
yes,
substitute
yes.
back before performing the integration. The value of a is
Okay.
2 and the value of b is negative 3. So now you do the integration. So integration of 2
Okay.
by x, it's 1 by x only. So integral 1 by x is log x, isn't it? And 1 divided by 2x
Yes,
minus
ma'am.
1.
Yes.
It's log of 2x minus 1, that's it.
Okay.
So before doing the partial fraction, we are using the remainder theorem on that. So here you do have x square plus 1 and into
Okay.
x minus 1. So here you do have a quadratic equation and an expression. So whenever you
Okay.
have a quadratic
Okay.
equation in the denominator, you have to write ax plus b in the numerator.
Okay.
And you have an expression
Okay,
here,
ma'am.
so writing the variable in the numerator itself fine. So it's ax plus b divided by x
Okay.
square plus 1 plus c divided by x minus 1. So now you again,
Okay.
the same process you have to repeat. You just have to take the LCM, cancelling the denominators, equate the numerator by substituting the values of x. How will you substitute? You
Okay.
have x minus 1, so you will substitute x as 1. You have
1.
plus
Yes.
1, so you will substitute minus 1. Isn't it?
Okay.
So by
Yes,
substituting
ma'am.
the values, and for finding the third value, you don't have any other number. You do have only minus 1 and plus 1. So for finding
Yes.
the third value, you can use 0 also. You can substitute x as 0 also for
Oh,
finding the third variable
okay.
value. So after finding the value of
Okay.
a, b and x, you just substitute in the very first equation.
Okay, ma'am.
Substitute in
Okay.
this equation and then you perform integration.
Great. Okay.
This question. So you have x minus 1 the whole square. So you just have to observe
Okay.
how do we, the way we write in the partial fraction. So x minus 1 the whole
Okay.
square can be written as a divided by x minus 1 plus b divided by x minus 1 the whole square. And for
Okay.
x plus
Yes.
2, you can write it as a separate factor. So now
Okay.
again you will go for LCM,
Okay.
right? Cancel the denominators,
Yes, ma'am.
equate the numerators. Again,
Okay.
you have plus 2, so you can substitute minus 2 in your x, and you have minus 1, you can
Okay.
use x as 1, you can substitute x as 1, and you can,
Okay.
you do have only these two numbers, so you can use x as 0 also. So you can
Okay.
substitute x as plus 1, negative 2, and 0. Okay?
Okay. Okay, ma'am.
So you can find the value of a, b, and c. Just substitute them over here and then you do the integration. So it will become log
Okay.
of x minus 1. And here it
Okay.
will become log
Yes.
of x plus 2. But here if you notice you have x minus 1 the whole square here.
Oh,
So let's
yes.
solve that separately.
Okay, ma'am.
You just take x minus 1 the whole square as 1 by 3 into x minus 1 the whole power minus 1 by 2, minus 2.
Okay, ma'am. Okay.
Yeah. So now you apply power rule. it will turn into 1 by 3 into x minus 1 whole power minus 2 plus 1 upon minus 2 plus 1, isn't it? So minus 2
Yes,
plus 1
ma'am,
is nothing but minus 1, and in the denominator also will have minus 1. So it will become minus 1 by 3 into 1 divided by x minus 1. Can you follow?
Yes, yes, ma'am.
We just used power rule on that.
Okay, ma'am. Yeah.
So over here also. So you have an expression and in the denominator you have a cubic equation. So again you have to use the remainder theorem, isn't it? So you have to consider this as the divisor.
Okay.
And this as the dividend. Just a second.
Okay.
Just a second. Before to that, you can still simplify this. Okay. The cubic equation can be simplified as
taking x.
You just take the x outside.
Okay.
Or else x square. You take the x square outside. If you take x square outside, you will be left with x minus 1. And you have minus x plus 1. Which can be written as, you just take the minus in outside, it will become minus of x minus 1. So now you take 1 x minus 1 as common. So it will become x square minus 1.
X minus 1. Yes.
So now you can write it like this. So this x square minus 1 can be written as x square minus 1 square. So now this is in the form of a square minus b square, which can be written as a plus b into a minus b, isn't it?
Yes, ma'am.
Can we write it as x plus 1 into x minus 1?
Yeah, ma'am. Yeah. Okay.
So now you can write it as a divided by x plus 1 and b divided by x minus 1 and c divided by x minus 1 the whole square.
Whole square. Yes.
Got it? So again you have to take LCM and then you will be cancelling the denominators, equate the numerators by substituting the values of x as -1, +1 and 0.
Okay.
Okay, you will make these three substitution for finding the values of a, b and c.
C. Okay.
Once you did that, you just have to substitute over here and do the integration individually for all the three terms.
So you get log.
You know how to do it. You will just get the answer in terms of log.
Log, yes.
At last, if you want to simplify, you can use log a minus log b formula.
Log formula. Okay, ma'am.
And this question is also very simple. It's pretty simple.
Okay.
X square minus 1 can be expressed as x plus 1 into x minus 1. So a upon x plus 1 and b upon x minus 1 and c upon 2x plus 3.
Yeah.
Take LCM, cancelling the denominator, substituting the value of x as -1 +1
0
from this.
0.
If you equate it to 0, 2x is equal, x is equal to -3 by 2. So we'll substitute x as -3 by 2 and you will substitute x as -1 and you will substitute x as +1. Understood?
Okay. Yes, ma'am. Yes.
So +1, -1 and -3 by 2. These three substitution you will make for finding the value of a, b and c and then you do the integration. Clear?
Yes. Yes, ma'am.
This question also, x square minus 4 can be written as x square minus 2 square.
X square.
And 2 square can be written as x minus 2 into x plus 2. Again, you do the partial fraction. You will be writing it as a upon x plus 1 and b upon x minus 2 and c upon x plus 2. So again, you take LCM and by cancelling the denominator, you can equate the numerator. So you will substitute the value of x as -1, -2 and +2.
+2. Okay.
Okay.
Yes, ma'am. Yes. Got it.
Okay, this question. You have a cubic equation in the numerator and a quadratic equation in the denominator. So you can go for remainder theorem here. So just take the numerator as the dividend. This as the divisor. After performing the division, you will write it as quotient plus remainder divided by divisor.
Okay.
And then you will perform the integration. Clear?
Okay. Yes, ma'am. Yes.
And this is also very simple. I told you already, if you notice any quadratic equation in the denominator, you have to write an expression in the numerator. For x minus 1, it's
Yes.
just an expression, so you can just simply write a variable on this. If you have an
Okay.
equation, you have to make a expression in the numerator. So 1 plus x square.
Okay.
For 1 plus x square, you have to write two constant
Okay.
with one variable, bx plus
Okay.
c.
Okay, ma'am. Done.
And after that, again LCM, cancelling the denominator, substituting the values of x, finding the value of a, b, and c, and then integration. Same story.
Okay. Okay, ma'am. Done. I did.
X plus 2 the whole square can be written as x plus 2 and x plus 2 the whole square. Okay, do not forget to write x plus 2 the whole square again. Okay.
Okay, ma'am.
So when you take
Okay.
LCM, we'll be cancelling out the LCM and then equate the numerator. Same. So here you do have only one number, which is x plus 2. So you can substitute x as minus 2 and you can make the substitution of x as 0.
Okay.
Same, x power 4 minus 1 can be written as 1 upon x square the whole square, 1 power square.
Okay. Okay.
Again, you can express this as a plus b into a minus b formula. A is x square and b is 1 in this. Understood?
Okay, ma'am. Okay.
So for x square plus 1 and x square minus 1. For x square plus 1, you can write it as ax plus b. And for x square minus 1, again you have to write it as x plus 1 into x minus 1. Understood?
Okay.
So
Yes,
you will
ma'am,
write
yes.
the variable on the numerator. C and D.
Okay.
So here you do have 4 variables. So you will do 4 substitutions. X is plus 1,
Okay.
x is minus 1, and x is 0.
Okay.
Yeah. Simple only.
Okay.
Okay. So they gave a hint. You have to multiply the
Divide. Okay.
denominator by x power n minus 1 and x power n minus 1. They're solving it using the substitution method.
Okay.
They're multiplying it.
Okay, it's an easy question, ma'am.
They're substituting sin x as t in this. Cos x upon 1 minus t, 2 minus t, dt by cos x. Cos x and cos x will cancel, dt upon 1 minus t into 2 minus t. So now you can go for partial fractions. A upon 1 minus t plus b upon t minus
Then
2
splitting
minus t.
the. Yeah. Yes.
And then you will go for LCM. And then you will equate it to the question, and then you will cancel the denominator.
Values.
And again, you will substitute the value of ts plus 1 and ts plus 2
Yes.
for finding the value of a and b.
Okay. Okay, ma'am. Done.
This is also kind of easy. They just replaced x square as t in this. They brought this.
Okay.
And then they are multiplying the numerator and multiplying the denominator for creating a quadratic equation. You have a quadratic equation in the numerator as well as in the denominator. You can use remainder theorem. Always the numerator will be your divider and the denominator will be your divisor. And when you perform division, the remainder theorem would be q plus quotient plus remainder upon divisor, isn't it?
Yes.
Integrate them separately, you will get the answer.
Okay. Done.
Partial fraction, LCM. This is also, they just replaced x square as t in this.
Okay. Okay.
And then they are
Yes.
performing the
Substitution and then partial fraction.
partial fraction.
Okay.
Partial fraction, LCM, cancelling the denominator, finding the value of a and b, substituting back, then you are integrating.
Okay.
At last, you have to write the t in terms of x. Because your
Okay,
question is
ma'am.
in the form of x.
X. Okay. Yes. Okay, ma'am. See some
Multiplying and dividing it by x power 3. So they are assuming x power 4 as t. So 4x cube is dt by dx. And then just substitute them. Rewrite your question in terms of t. It will become dt upon t into t minus 1. So using partial fraction, you can write it as a upon t plus b upon t minus 1. Take LCM. And then you cancel the denominators. Equate the numerator alone. When you substitute t as 0, you'll be able to find the value of a. And when you substitute t as 1, you'll be able to find the value of d. Again, you substitute the values of a and b in this. And you perform integration. So integral 1 upon t is log t. Integral 1 upon t minus 1 is log t minus 1. Log a minus log b can be written as log a by b. Clear?
Yes, ma'am. Yes, ma'am. Very clear.
This question also, they're just assuming e power x as t. They gave a hint. So differentiate both the side. You can change your question like this. Similarly, like a upon t plus b upon t minus 1. Same question. Same question. At last, you just have to replace your t in terms of x. That's it. That you should not forget. Same kind of questions only. That's all about this exercise. 7.6. Okay, 7.6 deals with the isolate rule. Do you remember?
Yes, ma'am. Yes, yes.
Isolate. I is for inverse trigonometry, L for logarithm, A for algebra, T for
trigonometry, and exponential.
Exponential, yeah.
Yes.
This is how we'll give reference. So x into sin x.
Yeah.
So according to isolate,
yes,
A comes before trigonometry, isn't it?
trigonometry.
So you will assume the first as f of x and sin x as g of x.
G of x.
So whenever we have two functions in the form of multiplication, f of x into g of x, you will rewrite that as f of x integral g of x dx minus integral f dash of x integral g of x dx into dx. This might look big, but if you broken down this into a small part, then it would be very easy. We'll find what is integral d of g of x and f dash of x. And then just substitute over here and it would be very easy.
Yes, ma'am. Yes.
So g of x is sin x. Integral sin x is nothing but cos x.
Minus cos x. Yes, ma'am.
Yeah, minus cos x.
Yes.
Yeah. And what is f dash of x? F dash of x means differentiation. Differentiation of x is 1. Yeah.
1. Yes.
So that would be 1 only.
Yes.
And integral g of x again. Integral sin x is nothing but minus cos x. Minus of minus cos will give you plus cos.
Plus
cos.
Yes.
So plus you have integral sign already here. So that integral is here. So integral cos x is nothing but sin x. So minus x cos x plus sin x plus c. Clear?
Okay. Yeah, ma'am. Very clear.
That's it.
Okay.
This is pretty easy. So this question is also same kind. So you will give preference to according to the isolate, you will assume this as f of x and this as g of x. Again, you have to use the same formula. So this form you have to use it.
Okay, ma'am. Done.
The third question. For the third question, you have x square and e power x. E is exponential. So according to isolate rule, you will choose algebra as f of x and exponential as g of x. Okay?
Yes, ma'am. Yes.
So again, you have to substitute in this. It's going to be very easy.
Okay.
And differentiation of x square is 2x and integration of e power x is e power x only. Very simple integration and differentiation.
Okay.
This one also. According to isolate, I-L-A, isn't it? So LA,
Yes, ma'am.
logarithmic
So log
function
x will
comes
be f
before
of
to
x.
algebraic. So you will choose this as
Yes,
f
ma'am.
of x. So f of x is
yes.
going to be your log x and g of x is going to be your f of x. Clear?
F of x. Okay, ma'am. Yes, ma'am. Very clear.
This question also, again, log of 2x is going to be your f of x and g of
Okay.
x is going to be your x.
X.
So
Yes.
integral g of
Yeah.
x. When you
Yeah.
integrate log of 2x, integral log x will give you 1 by x.
1 by 2x
So 1 by
into
2x
differentiation of
into
x.
2.
Yeah. Yes, ma'am.
And integral x is x square by 2. That is also pretty easy.
Yes.
I'm sorry, we are
Okay.
not integrating the log 2x. We are
Log x.
differentiating. Sorry.
Differentiation. Ma'am. Yes.
Integral
Yes.
1 by x is log x. Differentiation of log x is 1 by x, vice versa.
1 by x. Yes, ma'am. Okay.
Clear?
Yes, ma'am. Very clear.
This question, hence by highlight, you will assume log x as f of x and x square is g of x.
G of x.
Understood?
Okay.
So it's f
Yes,
of x
ma'am, yes.
integral g of x minus f dash of integral f dash of x into integral g of x dx into dx. So you know what is f of x? It's log x and
Yes.
integral g of x. When you integrate x square, you will get x square by 3. That you will write it here.
Yes, ma'am.
Minus integral,
Okay.
put the integral sign again. What is differentiation of f of x? Differentiation of f of x is differentiation of log x, which is 1 by x. Okay.
Yes.
Again,
ma'am.
integral g of x, it's x cube by 3. Yeah. So
Okay.
1 by x into x
Okay.
cube by 3 will give you the result as x square by 3.
Okay.
Again, you will integrate it. Take the 1 by 3 outside. X square will become x power 3 upon 3 plus c.
Okay, ma'am. Done.
So we'll solve this exercise according to the highlight.
Okay, ma'am. Done.
What is this? Okay, directly click the 18. Sine inverse of x also. Okay, this is substitution method.
Okay, ma'am. Okay. So, eta.
X is sine theta. X is sine theta. When you
Instead of t,
differentiate
we're
both the
taking as
sides,
theta.
you will introduce a new variable here. So when you
Okay.
assume, I mean substitution, nothing much. So when you
Okay.
assign this inverse trigonometric function to a variable, you will differentiate both the sides. Here
Okay.
you have assumed sine inverse of x is theta, isn't it? So you will differentiate
Yes,
with
ma'am,
respect to theta here. So x is
Okay.
sine theta. So when you differentiate x with respect to theta, it will turn into dx upon d theta, and sine theta will turn into cos theta.
Okay, ma'am. Done.
And then you will rewrite dx as cos theta into d theta. So now let's
Okay.
change the question. Sine inverse of x
Okay.
can be changed as, how can you change? What is sine inverse of x? It's theta. Yeah.
Theta.
So
Yes,
theta
ma'am. So theta
square.
square.
And what is
Yes, ma'am.
dx? Dx is cos theta d theta.
Dx cos theta. Yes, ma'am. Yes.
That is how we changed. So now if you look
Okay.
at the theta, it's just an algebraic. This one is
Okay.
a trigonometric. So now you can use
Okay.
highlight rule. So a
Yes.
comes before to t. So you will assume theta square as f of x and cos theta as g of x. Okay?
Okay. Okay, ma'am. Okay.
You're getting it?
Yes, ma'am. Yes.
X into cos inverse of x upon 1 minus x square. So again, the same substitution method. Assume the
Okay.
inverse trigonometric as a t. When you differentiate both the side, you will be getting minus 1 upon square root of 1 minus x square dt by dx. So dx is equal to minus square root of 1 minus x square dt. Just change the question in terms of t. Substitution method.
Okay.
So when you change the question in terms of t, still you do have x. So how can you change x? Cos inverse of x is t. So x can be written as cos t, isn't it?
Okay.
Can we do that? Just multiply both the side by
Yes.
cos. Okay.
Yes, ma'am.
So this
Yes.
x will
Yes.
turn into cos. So cos t into t. So again you'll go for highlight rule. Clear?
Okay. Yes, ma'am. Yes.
So t is going to be your f of x, and trigonometry cos t is going to be your g of x.
Okay. That.
So here, before using the isolate rule, we are just going for the substitution method. So x and secant
Yes.
square x.
Okay.
Secant square x is trigonometric and x is algebraic. So this one you will
Okay.
consider as
Okay.
the x is going to be f of x, and x is going to be f of x, and secant square x is going to be your g of x. So
Okay.
you know how to integrate g of x. Integration of secant square x is nothing but tan x. And differentiation of f of x. What is differentiation of x? It's 1 only. Yeah.
Okay.
It would be very
Okay.
simple. It's a simple question.
Okay, ma'am. Okay.
Again, tan inverse of x. They just wrote the tan inverse of x as tan inverse of x into 1. Okay. They're assuming
Okay.
1 as the algebraic and tan inverse of x as the inverse.
Okay.
Okay.
Okay, ma'am.
In case if you find tan inverse of x the whole square, again you will go for the substitution method. Okay. You will assume tan inverse of x as theta, and you will differentiate both the side. You will do what is dx by d theta and all that.
Okay, ma'am.
You're getting it. I mean, x
Yes,
is equal
ma'am.
to tan theta, and you will differentiate tan theta with respect to theta. If you have square, I'm saying, in case if you have square in your question with the inverse trigonometry. So here you don't have any x. It's just an inverse trigonometric function. So you can rewrite the inverse trigonometric function as tan inverse of x into 1. 1 can be considered as algebraic because it is x power 0. Clear?
Yes. Okay.
According to the
Yes,
isolate
ma'am.
rule, you'll give priority to this. So this is f of x and this is g of x. Substitute in this form. That's it.
Okay. Okay.
Clear?
Okay. Yes, ma'am. Yes.
And x into log x the whole square. Same. Algebra is going to be your x, and logarithmic is going to be your g of x. That's it.
Okay. Okay, ma'am.
X into e power x upon 1 plus x the whole square. They're just adding and subtracting 1 in the numerator. 1 in the numerator.
Okay.
They're grouping it like this. Okay.
Okay.
They will cancel out this and this.
Okay.
I think this you are very familiar. Do you remember?
Yes.
Integral e power x f of x plus f dash of x into dx. Do you remember? Which can be written as e power x into f of x.
Yes.
Yeah.
Yes.
So it is in that form.
Okay. Yes, ma'am.
So the thing is, you have to find f of x. So this is your f of x.
Okay.
And when you differentiate this, you will be getting this as the f dash of x.
Okay.
Understood?
Only if that condition is satisfied, we can use this formula. No?
Formula, yeah. E power x into f of x plus f dash of x means you can write it as e power x into f of x plus c.
Okay, ma'am.
Clear?
Yes, ma'am.
So e power x into 1 plus sin x upon 1 plus cos x. So they're just rewriting sin x as 2 sin x by 2 cos x by 2 by using the half formula. And 1 plus cos x, they are writing it as 2 cos square x, x by 2.
Yes. Okay.
So they're just rewriting this as a square plus b square plus 2ab into a plus b the whole square. No. A plus b the whole square. Okay.
Okay, ma'am. Okay.
They're taking the 2 outside, and for these 2 square, you have square in the numerator and denominator, so you can put whole square.
So the whole square. Okay.
This cos x by 2 is common for these 2 terms. Split them.
Okay. Splitting and
Sin x by cos x by 2 can be written as tan x by 2. Cos x by 2 by cos x by 2 is 1. So again, they're using a plus b the whole square rule.
Whole square formula. Okay.
And we don't have any formula for tan square integration. So just express them in the form of secant square minus 1. So it will become secant square x by 2 minus 1. You have plus 1 here.
Yes.
Plus 1 and minus 1 will cancel out each other. You will be left with secant square x by 2.
Okay, ma'am.
Clear?
Yes, I did. Yes, ma'am. Yes, clear.
So now you do the integration. You don't have to do the integration if you check this sum. So you have f of x here, f dash of x here, and e power x. So now this This is in the form of e power x into f of x plus f dash of x dx, isn't it?
Yes, ma'am. Yes.
Which can be written as integral e power x into f of x dx. Yeah.
So e power tan x. Yes, ma'am.
E power x into tan x by 2 plus c.
Okay. Okay, ma'am. Yes.
Same. When you differentiate 1 by x, the answer is going to be negative 1 by x
Oh,
square
yes.
only. Pretty direct.
Okay.
So you can write it
Yes,
as e
ma'am.
power
Yes,
x
yes.
into f of x, which is e power x into 1
So
by
e
x.
power
That's
1 by
it.
x plus c. Okay.
Into 1 by x plus c. Into 1 by x.
Yes.
f of x is 1 by x in this.
Okay. Okay. Yes.
Okay. Remaining questions are in this form only. So if you find
Okay.
e power x into f of x plus f dash of x dx, you just have to write your answer as e power x into f of x plus
F of x plus c. Okay, ma'am. Done.
Okay. Yeah.
Yes, ma'am.